We would proceed in the on the parameterization in calculus. So parameterization or full-fledged kind of vector-based calculus. If we see calculus, then it is a game or it is a science of algebraic equation. If we have algebraic equation, then through calculus we can play with it. So it's a game of algebraic science. Now, algebra can be single variable, like only single independent variable, that is x only, or it can be dual x and y, or it can be triple x y z, or it can be multivariable, more than three. So this is the situation of kind of multivariate calculus, where calculus is a game of algebraic equation. But there are limitations in algebraic equation. If I say that I have a vector and that is 2i plus 3j plus 4k, then immediately someone can place a point 2, 3, 4, origin, draw a line. Achha, this is the direction of the vector. But same thing we saw, same thing we can achieve in algebra, where 3z equal to 6x plus 4y, or 6x plus 4y minus 6z equal to 0. Now you tell me what someone would understand with this. Nothing, right? Means 2i plus 3j plus 4k. Someone would understand immediately that what is the direction. What about dz by dx? Then 4 by 2. What is dz by dy? Partial derivative along x-axis and y-axis. This is why algebraic equations are famous. If I have a surface, if I have a 3D surface, then in 3D surface, quickly I can calculate if z is dependent component, then dz by dx partial derivative along x-axis, dz by dy partial derivative along y-axis. Okay. Now, if I say 2i plus 3j plus 4k, then 4 is the, if x varies 2 times, then z varies 4 times, 2i plus 3j plus 4k. In that sense, the dz by dx will be 4 by 2, that is 2, and dz by dy, that is 4 by 2. So direction and partial derivative, everything is crystal clear in vector. What is not crystal clear, that we will address through parameterization, parametric functions. That is the concept. So can we replace algebraic equation altogether in calculus and work with the vector? That is a kind of a struggle that people are doing, people have been doing. I believe that people will not be doing. So that is the idea. Now, what about so what we have seen till now is I have a vector that is 2i plus 3j plus 4k. Then equivalent equation in algebra is z equal to 4 by 2 dz by dx x plus 4 by 3, that is dz by dy y. Okay. Now, so nice. If I say, if this is the line we are talking about, then we have shifted this line to 0, 0, 2. There is another line. So this is the equation of line, that is 3z equal to 2x plus 6x plus 4y. Now this line is like this. If I draw a parallel line or lift this line little up along z axis, 0, 0, 0, 0, 2. 2, if I make the offset, then it will become z minus 2. Z 3, 3z instead of 3 inside braces z minus 2, because we have shifted z 2. So 3z 3 z minus 2, or 3z minus 6 equal to 6x plus 4y. So minus 6 came into the picture. So if I try to move the line from here and there, if I add some offset, or if I say that interception at z-axis is this, or the line of surface is passing through this point. If surface equation is 3z equal to 6x plus 4y, and if I say it is passing through point 002, it is as good as saying same thing. Then it is then equation would be z minus z0 equal to dz by dx, x minus x0 plus dz by dy, y minus y0. If that is the case, then surface is now passing through a point that is x0, y0 and z0. These things are pretty simple in algebraic equation. That's why algebraic equations are being used in calculus. This is one thing. Second thing is that in one go, if I say that z equal 6z equal to uh, 3z equal to 6x plus 4y, then in one equation, or if I say that 6x plus 4y minus 3z equal to 0, then in one equation we have all three variables. Now I can calculate partial derivative along x-axis, y-axis and z-axis, calling it as gradient vector. So everything is all together in algebraic equation. There is nothing called x component, y component and z component. This is Boole and this is Bain also. So Boole in a sense that everything is together. But Bain is we don't know what is x component, y component and z component. If we don't know x component, y component, and z component, then we cannot estimate the direction. So that is the something that is missing. Okay. Now one idea is that we can do something in the vector so that we have direction, magnitude, and then lavishness of everything get together as what we see in algebraic equations, so that the calculus fundamentals would be easy in vector also. Now, now we are proceeding. So now we are talking about kind of shifting the line to any point. So if I had a line that passes through origin, I have made a shift now passing through 002. It is to offset in z direction. So I can give offset in any x0, y0, z0, claiming it is passing through that point. So three things we have talked: vector equation, algebraic equation, and parametric equation. So parametric equation, if I say 2i plus 3j plus 4k is the equation of vector and x component is 2, y component is 3 and z component is 4, then can we now have a vector equation as independent component as only one, independent variable is only one. 3 multiple independent variable we cannot afford in vector. Anyway, we have x component, y component, and z component. Then what multivariable you expect now? So in x, we have everything that is based on x, xi, yj. In y component, everything is based upon y. In z component, everything is based upon z. If that is the case, then complex equations are not possible. Sometimes if you see algebraic equation, all are it together. Like algebraic equation can be x square plus y square plus z square equal to 9. All are together, and then equation can vary in a way that whatever we have dependent component, if my equation is in x, y, z, then density function f x, y, z is on x, y, z. So f x, y, z equal to x square plus y square equal to z square. Then I have altogether three independent components are varying. That is not the thing in vector. We have three components separately. So we cannot go for multivariate in vector notation. So there is limitation. Vector has its, I would rather say vector has its own grammar. So which has x component, y component and z component. That is not the case in algebraic equation. There are independent components and there are dependent components. And independent and dependent components, they are kind of related to each other with the rate of change, that is called slope, dz by dx, dz by dy. But here in vector, there are three vectors all together. If I say 2i plus 3j plus 4k, 2i is a separate vector that is moving in x-axis, one is moving along y-axis, one is moving along z-axis. and they combine together at origin and then move along. So the formation of vector is completely dissociated. We can kind of break the vector notation into separate vector at all, orthogonal vector at all. That is not how you will break fxyz equal to x square plus y square equal to z square. You cannot break. So algebraic equation has completely different signs at all, and based upon that science, integration and differentiation or other any calculus methodology is based upon, whereas vector is nothing but it's a combination of orthogonal vectors. That's it. So 2i plus 3j plus 4k, you understand now that it is combination of three vector 2i, 3j and 4k. So that is the concept of a vector. Now if I try to make an independent variable here, only one independent variable, it can kind of accommodate where same independent variable would be spread across x component, y component and z component. In x component, you cannot take 5 independent variables. Then in y component, 5 independent variable. In z component, 5 independent variable. Anyway, there are three orthogonal components are available there separately. What independent variable you will take? Not possible, right? Whatever the independent variable you are thinking, they are anyway available as independent component as far as vector is concerned. X, Y, Z are separate. What extra you would take? So only place where we can push in, we can kind of sew, or we can hook hook in inside the equation. The independent variable is where the x, y, z are would become dependent variable now, and they would be dependent upon a single independent variable. So we call it t. So now t is the single independent component on which x, y, z would be dependent upon. Okay, that is the concept that we are throwing inside the vector. So if vector is 2i plus 3j plus 4k, then I can say it is 2ti plus 3tj plus 4tk. If x is 2t, then variation in y what we see is 3t. Then it is 4t. Now equation of the vector is 2ti plus 3tj plus 4tk, where x equal to 2t and y equal to 3t and z equal to 4t. Now, if I see the algebraic equation, then 3z equal to 6x plus 6x plus 4y. Now, if I see the relationship between z and x, then I have to keep y constant, so I can make it 0. Then 6z equal to 6, sorry, 3z equal to 6x, then z equal to 2x. This is what we are saying. So if x is 2t, if x is 2t, then z is 4t. Z equal to 2x. If x I replace with 2t, then z equal to 4t. Same thing we are seeing there. Now, if remove x or make it x0, then the relationship between z and y, then 3z equal to 4y. Then if y is 3t, then z is 3z equal to 4y. If y is 3t, then 3z equal to 12t. In that case, z equal to 4t. So same thing we are seeing in algebraic equation. So anyway, now we'll proceed through the vector one. But that is the concept of the discussion. So now the vector equation, we had 2i plus 4j, 2i plus 3j plus 4k, that is x component, y component and z component. Now it is now modified to 2ti plus 3tj plus 4tk, where x component, y component and z component, they become dependent component upon another independent component, that is t. Now here it is t. Upon t, x, y, z, they exist. Now, the main question here, why the vector is lagging from algebraic equation, is that any vector, there are two kinds of vector. One is position vector, one is displacement vector. If I say that I have a point 2, 3, 4, then can you tell me what is the vector? Then it is implicit that vector should be vector should have a direction and magnitude. If I say there is a point 2, 3, 4, what would be the vector? Then certainly implicit is that there is another point that is 0, 0, 0. If I draw a line from 0, 0, 0 to 2, 3, 4, 0, 0, 0, 0, 0, 0 to 0, 0, 0 to 2, 3, 4, then we have a line that is passing through origin. And then 2 minus 0, 3 minus 0, 4 minus 0 is the equation of vector, that is 2i plus 3j plus 4. So this is the equation of vector which passes through the origin and point 2, 3, 4. Now, idea is if this is the vector, this is the origin and this is 2, 3, 4, can I lift it to 2 offset in z direction to 0, 0, 2? That is the question. Now, we cannot do. Okay. So, if I do this, then it would pass through another point that would be 2, 3 and 6, because that side, if from origin it lifted 2 in z direction, so 2, 3, 4 it will also lift in z direction. So 0, 0, 2 and 2, 3, 6, there are 2 points through which the vector would pass now. This is called displacement vector, where both ends, none of them are origin. Otherwise, if one end is origin, that is position vector. And if it has 2 points and none of them is origin, that is displacement vector. Everything is position vector. Okay. So 0, 0, 2, 0, 0, 2 one end and other end is 2, 3, 6. If I draw the vector, then I have to subtract. So 2, 3 and 6 minus 2, 4 only. So 2i plus 3j plus 4k is the equation of displacement vector only. So all vectors are position. This is the place vector lacks heavily from the algebraic equation. One place. Another place, that is the displacement, and another place is there are no independent variable. But anyway, we have pushed now, right? So 2ti plus 3tj plus 4tk, where t is anything. It is minus 1, any integer. Now it can be 0 also, but whatever. Still, so now we know that vector we cannot shift its position. Vector has a fixed direction that is passing through the origin, and then it has a magnitude. That vector has a is a energy that has a direction through origin, and it has a magnitude. That's it. Now we are trying to come up with a vector which gives a full-fledged status the way we have in algebraic equation. That is the question. So first is, can we shift the vector along z-axis 2 or 002, or it would pass through a point that is 002, and that end also is shifted, that is 236. So 002 and 236, it's not possible. Okay, we have to make it possible. Anyways, now if I see the parametric equation in vector, that is 2ti plus 3tj plus 4tk. Okay, parametric. What is parametric? Parametric is nothing but x, y, and z components are now, they are dependent upon t. If I say z is dependent upon x and y in algebraic equation, then fxy equal to z. Z component is dependent upon two independent components x and y, then z equal to function over x and y, z equal to fxy. Okay, that is z equal to x plus y, x square plus y square, square root of x plus x square plus y, whatever. But if I say z is dependent upon x and y, this proves that z equal to function over x and y. If that is true, then if I say now x, y, z are dependent upon t, then x, y, z are function over t. Now earlier x was 2, y was 3, and z was 4. Now x is 2t, y is 3t, and z is 4t. Then x is a function over t. So x equal to ft, y equal to gt, and z equal to ht, where f, g, h are functions over t. What we are pushing algebraic equation inside the vector, knowingly, unknowingly. Now if there are if there is one independent component and three dependent components. You remember that if I have two independent components x and y and one dependent component in algebraic equation, then only one function exists, that is fxy. Now we have three dependent component and one independent component. So three functions would exist. Okay, x equal to gft function over t, g equal to y equal to gt, and z equal to ht. F, G, and H. Now there are three functions exist because there are three dependent components and all are dependent upon independent component T. Now, knowingly, unknowingly, we are trying to push algebra inside vector. Now, vector, each component has equation now, but it must be restricted. It must be confined to single independent variable. Otherwise, we will land up in a situation where there is no path to go. Okay, so now we have equation 2ti plus 3tj plus 4tk. Now idea is, now behaving like algebra is done now. We have function over independent components. So this we have achieved. Only thing is, can we shift now? The vector is here, then vector should sit its location. But the way we call it displacement vector from position vector, but there is no displacement vector. We saw, even though it passes through 2 points and none of them is origin, we have to subtract these 2 points and finally it will become a position vector. So to get the kind of actual displacement vector in calculus, vector calculus, I would say, or parameterization. So let's proceed. So now we have called vector called 2ti plus 3tj plus 4tk. Now we want displacement vector. This vector would shift 0, 0, 2. Can I take t out? So it will become t in bracket 2i plus 3j plus 4k. Same thing. Okay, if I take out t, and when t is 0, I consider t as independent variable. Anything independent variable is possible. So I make t equal to 0. If I make t equal to 0, then when time is 0, then it should be at the origin. But it is gone, null. If t is 0, there is nothing. This is what we don't want. First, leave the shifting the vector, giving the offset to the vector. We are making it vanished. T braces 2i plus 3j plus 4k. If t is 0, then it is gone. It should be 0, 0i, 0j and 0k. Time t equal to 0, the vector is at origin. This is because vector has 2 points. One is origin, other is 2, 3j. So when t is 0, it should sit at origin, but that is not the case. Then 0 comes into the mathematics. Power of 0. In mathematics, power of 0. You cannot underestimate 0. Okay, so 0 is probably the most powerful number in mathematics. The most costly or most powerful invention that happened, discovery or invention, whatever, that happened in mathematics as far as number game is concerned, that is 0. Okay, so if you start complex equation with a hidden 0, if 0 is hidden, right, hidden 0, then you can come to an equation that probably you have also not dreamt about it. So now we have t 2i plus 3j plus 4k. So t in bracket 2i plus 3j plus 4k. Now can I add it with 0 vector? 0i plus 0j plus 0k, that is one vector, plus t in bracket 2i plus 3j plus 4k. Same thing. 0i plus 0j plus 0k, one vector, plus t in bracket another vector, 2i plus 3j plus 4k bracket. This explanation is not available in any book. Okay, you can find it out anyway. So we are going to make this also as a kind of disclosure. All videos are disclosure. So that's why we are saying we will have 500, 1000, 2000 disclosures. Okay. So, or 10,000 disclosures. So now we have zero vector that we have added now. So 0I plus 0j plus 0k. One vector plus t, another vector 2I plus 3j plus 4k. When t equal to 0, we have zero vector in our hand. So our vector that is passing through 0, 0, 0 and other n is 2, 3, 4. When t equal to 0, then it is passing the origin, that is 0I plus 0j plus 0k. When t equal to 1, then 2I plus 3j plus 4k. So when t equal to 0, we are at origin. T equal to 1, we are at next hop. When t equal to 2, then 4I plus 6j plus 8k. Same line, only is magnitude of the vector is growing. Otherwise, direction is same. Are we getting the hint now? That can we make a displacement vector actually the dream come true? Can I replace zero vector with another vector? This is not available in any book. So if I say 0I plus 0j plus 0k plus